Good day everyone, my name is Cedric Campanel. I'm going to be presenting to you an example of basic integration in Calculus 2. So the first topic is the integration of algebraic functions. So our first problem is integration of dx. In order to solve that, we must solve for the integration of dx, which is x plus c. Whenever we have a final answer, we always place plus c, since plus c is referred as the constant of integration. And to the second problem, we have integration of 7 dx. Since 7 is constant, we must separate it first and then place the integration dx. In order to find the answer, we have to multiply 7 to the integration of dx, which is 7 dx. Since now we bring down 7 here, and we all know the integration of dx, like in the first example, is x, so we just place it here, x plus constant of integration. And now for our third example, we have the integration of x dx. So for its formula, we have this integration of x. There's an exponent here, dx, and here is how we solve it. For example, whenever a constant or a variable has an exponent, we always add a 1 to it. We always add 1 to it, and then we also copy out its denominator. So so this is how you go. Integration of x and dx equals to x and plus 1 over and plus 1. So we basically copy the final exponent at the denominator. Here we have an example, integral of 5x cubed over 7 dx. What we do here, take out the constant, 5 over 7, integral of x cubed dx, and then we just bring it down again, 5 over 7, open parenthesis, we have to add 1 plus 1 to the exponent and copy it in its denominator. So 3 plus 1 over 3 plus 1, and then close parenthesis dx. After that, 5 over 7 will become now it's gonna be x plus 4 over 4 plus c, and then we multiply 5 to the x to the 4th power, making it 5x4 over 7 times 4 is 28. Oh, my handwriting is really bad, I apologize for that. 5x4 plus c, 5x to the 4th power over 28 plus c. Since since this is the final simplest or the simplest form, we can no longer simplify it, making this our answer. So this is the second example. As you can see, we made the first one here, but since I have trouble writing it down here, I just tried to do it again. So the problem is integral of 4x squared plus 3x dx. So we take out a constant, 4, integral of x squared dx minus 3, since 3 is also constant, positive 3 plus 3 integral of x dx. So as you can see, this is the what we're gonna do. We're just gonna add 1 x squared plus 1, 2 plus 1, and 3 here. Since x is understood as 1, since if it does not have an exponent like 2 or like squared or cube, it's understood as 1. So it's gonna be 1 plus 1, and the denominator 1 plus 1 also. And now here's the finished product. Just 4 open parenthesis x cubed over 3 close plus 3 x squared over 2. Now we're gonna convert this to the final answer. Oh, extra mistake in here. Equals to 4/3 x cubed plus 3 half x squared plus c. Don't forget to write plus c. So I take out the constant here, making it 4/3. You have to multiply 4 times x cubed over 3. So this is the answer. Same as the second one. Hello, so now we're gonna be solving for the exponential integration of exponential functions. So here's a basic example. Integral of ex dx. So what we did here is just copy ex plus c. And then I'm gonna add another example, which is e to the 5th x dx. So the answer our answer here is just copy e 5x and then the derivative of 5x, which is 5 here, plus arbitrary constant. So another example here, integral of x4 apologize, e x to the 5th dx. So it's basically similar as u substitution. We will take this x 5th and then our derivative, which is equals to 5x to the 4th power dx. So and then we solve for dx, which is du over 5x to the 4th power equals dx. What we're gonna do now is just bring here x to the 4th power. Since we substitute u, it's gonna be eu, and du over 5x4. Alright, so since these are, if you divide it and since they are similar, you just cancel both of them, not cancel culture. And then since the denominator 5 is understood that 1 is numerator, so we're gonna place here 1/5 eu du equals to, so we just transfer it here or multiply, will become 1 to the 1/5 eu plus c equals, we need to substitute it back once again, making it 1/5 e, instead of u now we have to substitute back, which is x to the 5th power plus c. So this is our final answer. Good day everyone. So now I'm gonna be presenting you an example problem or an example of logarithmic function based on the basic integration. I don't know if you understand what I said, because I cannot understand sometimes. So we have the following formulas in case we try to solve this one. So for the first problem, we have 2x plus ln of x dx. So we're gonna solve this. Integral of 2x dx plus the integral of ln of x dx. In a way we can solve this. We base 2x here in ax, so if we solve this, it will become 2x over, they're similar, right? So this will be the outcome, 2x over ln of 2 plus, since ln of x we have here similar also with the ln of x dx, which is this. Here is the formula. So plus L n of x minus, you can see x ln of x minus x plus arbitrary constant. So hello everyone, so I just charged my cell phone. Now I'm just in a different position now solving this. So I just rewrite the problem once again, or the formulas, and here's the problem. So this is integral of 3 over x minus 11 ex dx. So we're gonna solve it in two terms. I just have to split them up. Integral of 3x over dx minus 11ex dx. So they don't have a formula. What I did here is this is the closest thing. By that we can do this by performing the constant multiple rule. Making it so by isolating this 3, integral of dx over x is quite similar now, minus we also apply this constant multiple rule here, 11 integral of ex dx. So by following the formula, dx over x, we can apply this by putting 3 ln of x minus, since the formula is basically the same, we just copy it. There's no need to change or anything, we just have to place it back. So our answer is 3 ln of x minus 11 ex plus arbitrary constant. Thank you. Good day everyone. So now I'm gonna be presenting you an example problem, or an example of logarithmic function based on the basic integration. I don't know if you understand what I said, because I cannot understand sometimes. So we have the following formulas in case we try to solve this one. So for the first problem, we have 2x plus ln of x dx. So we're gonna solve this. Integral of 2x dx plus the integral of ln of x dx. In a way we can solve this. We base 2x here in ax, so if we solve this, it will become 2x over, they're similar, right? So this will be the outcome, 2x over ln of 2 plus, since ln of x we have here similar also with the ln of x dx, which is this. Here is the formula, so plus L n of x minus, if you can see, x ln of x minus x plus arbitrary constant. Good day. So now we're gonna be solving an example of trigonometric function. So the problem is integral of 5 sine x plus secant squared x dx. First we're gonna do is separate these two into two terms. So it will be 5 sine x dx plus secant squared, integral of secant squared x dx. After that we will use a constant multiple rule. We have to take out 5 first, we have to isolate it here, then sine x dx plus integral of secant squared x dx. It will now integrate the sign, so the integral of sine x dx is equals to negative cosine. First bring down 5 here, negative cosine x close parenthesis plus the integral of secant squared. All we know that it is tangent x, so it will be tan x plus c. It is now just an equation away to our final answer, which is we have to multiply this, negative 5 cosine of x plus tangent x plus arbitrary constant, and we have now our final answer. Good day. So here is the second problem, trigonometric function, integral of 8x cosecant squared x squared dx. First we're gonna get the u, which is the x squared, and then instead of dx we have to replace d over dx with respect to u. After that, took the integral, or the derivative of 2x, du over dx is equals to 2x. Since we are gonna get dx, we have to multiply this by dx, and if we want to, and we need to cancel this, we have to divide it by 2x, making it, the final answer would be d over 2x equals to dx. Now back to the problem. We have now 8x cosecant squared. Instead of x squared, now we substitute it to u, so it's cosecant squared u du over 2x. After that, we have to split up the 1 from over 2x from du, making it 1 over 2x here, times cosecant u du d over 2x equals dx. What I did here is I divided 8x to 2x, making it 4. Just bring down cosecant squared u du. After that, since it's constant, we have to split it up for a while, or separate it, isolate, what you call it. It's gonna be 4 integral of cosecant squared u du. Then take out the integral sign, put the 4 here, and the integral of cosecant squared, which is negative cotangent, and it's gonna be now 4 minus cotangent u du plus c. The last thing we need to do is now replace our substitution back once again, what we have replaced it for just a few minutes ago. It's gonna be now 4 minus cotangent x squared plus arbitrary constant. Hello everyone, so this is the number 1 example of integration by parts. For the first thing we do, we take u equals ex, and the du will be ex dx. Also, we need to find the dv, which is sine x, and then the v will be its integral, or negative cosine x. After that, the formula, by the way, is integral of u dv equals uv minus integral of v du. So you must follow that formula as always. Now we're gonna u, which is ex, just place it here, dv sine x equals, it's not equals, but it's actually equals, I forgot there in the formula, equals u once again ex, and then the v, which is negative cosine x, integral of v, which is negative cosine x, and then the u, which is ex. To simplify this, the only part we need to take is this part here. So we just bring this down. Ex negative cosine x plus, since it's double negative, it became positive. I actually forgot that there's a minus sign here, so, or subtraction sign. That's why it became positive. And just place this cosine x ex, and then the arbitrary constant, or plus c. And there we go, the final answer of the number 1 example. Now we're on our way for the second example. Integral of x cubed sine 4x dx. First thing we need to do is, our method is there, use the different and integral method. Different and integral. So this is a DI method that Sir taught us. Shout out to Sir Lagos. Okay, x3. This is how we do it, or this is how we do it. I just follow this formula. X cube, and then sine 4x. After that, took the derivative, 3x squared. I'm just gonna focus here for a while. Trick 7 3, 6x, and then 6 derivative, and then 0. While here sine x and sine 4x will become negative cosine 4x divided by 4. Then it will become again sine 4x. 4 times 4 will be multiplied and it will become 16. After that we have negative cosine 4x, 4 times 16, which is 64, and then sine x or sine 4x, 4 times 64 which is 256. So sir made this method. What we're gonna do here is we're gonna form this, but by forming we have to I don't know how to say this, but we have to pair this with the bottom number, or the pair this like this. You just pair it. We're gonna leave 0 behind since we have nothing to do with 0 anymore, and we're just gonna be starting in negative cosine 4x. Now, without further ado, let's start. 3x times negative cosine 4x over 4, it will become negative x3 over 4 cosine of 4x. Then do it again here, follow the pattern. 3 times, it will become 3 times 3x squared over 16x sine 4x. Continue the method. We have here 6x over 64 negative 6x, since it is six. Wait for a while. 6x cosine 4x. Sarap. Salay ka mo tabi mo. So hello everyone. Now we're gonna solve the second problem of the integration by parts. Our problem is integral of x cubed sine 4x dx. What we're gonna do now, I'm gonna use our master's method. Shout out to Sir Lagos for this method. He used the DI method, which is differential and integral. Different and integral method, where we take the derivative first. So x cubed take derivative x cubed will be 3x squared, derivative 6x 6 0. First 3x squared times 2 times 3, 6x, derivative 6x is 6, and derivative of constant is 0. After that, sine 4x to negative cosine 4x divided by 4. After that, it's gonna be sine 4x, 4 times 4 will be 16, then negative cosine, this is his partner, 4x, 4 times 16 is 64, and then the last one is sine 4x, four times 64 is 256. And now what we're gonna do here is take the partner of the for example, we're gonna take the partner of the x cube, will take the partner of 3x squared. So just follow this pattern here. So x3 will become x cubed over 4. Oh, it's gonna be negative since we multiply is cosine of 4x, and since you can no longer put the 4x since it's already here, second pattern, just took this, become 3x squared over 16 since it's 4 times 4, sine 4x. After that we will have 6x over 64, so it's gonna be negative cosine 4x. And then the last one, the way to avoid confusing, you don't need to add 0 since it's a constant and there's no value in it in this practice. 6 over 256 times sine 4x. Here we go. These are solid answers now, but these two can still be simplified. So we will try to simplify it, or place or negative 3, and then we have to divide it by 2, so 64 will become 32, negative 3 over 32 x cosine 4x. And then over here for the 256, you can also divide it by 2 or simplify it, become 3 over, instead of 256 we have to take the half, which is 128, and then sine 4x. The last thing we need to do is just copy it, making negative x cubed over 4 cosine 4x plus 3 over 16 x squared sine 4x. Also, I don't think it will fit here. I will just move it here. Just follow me again. Negative we got no money, clothes quite funny. And now we have after that just plus 3 over 32 x cosine 4x. And then the last part we will put minus 4 3 apologize, it's 3 over 128 sine 4x, and don't forget to add the arbitrary constant. I'm just gonna place it here, plus c. So this is the final answer. Don't forget the arbitrary constant. I just place it here because it won't fit in there. Thanks for watching. Hello everyone, so I'm now going to be solving a problem or an example of a dual integration formulas, which is the use substitution method. So now here is the problem. Integral of 3x times x cubed minus 9 squared. So the first thing you need to do is look for the u. When I usually identify u as the number that has a variable that has an exponent, or the one or the equation that is inside the open and close parentheses. So our u is x cubed minus 9 here. What I'm gonna do now is search for du. Oh, by the way, we must place dx here. D over dx. So our u is 3x, and since 9 is constant, we're just gonna leave it behind. And now our objective is to look for the dx. So in order for that, we must take out the 3x here by placing the dx on top of it. So we're gonna multiply this equation by dx over 3x, and after that, the what we'll get here is the du over 3x equals dx instead of 3x here. So we're gonna bring down the integral of 3x here, and since we substitute this to u, where we don't need to place that for now, we're just gonna put u here, u squared over here, du over 3x. So we're gonna perform our multiplication here. 3x times du over 3x, since they are the same, it will be equals to 1. You just need to cross it out. And now the only one will be remaining is the integral of u squared du. So by getting the integral of this with respect to u, we're gonna use using power rule for integration. So this will become, we're just gonna add 1 here. Just copy the denominator. Don't forget to put the arbitrary constant here instead of du. And now after that, just bring down the answer, which is u 3 over 3 plus arbitrary constant. Now what we need to do is just change it or substitute back what we have substitute before, which is the x cubed minus 9. So it's gonna be x cubed minus 9 over 3 plus c, and there we go, our final answer. Now we're gonna find the antiderivative of 4x times x squared plus 7 to the 4th power, or dx here. What we're gonna need to find first is the u, then its derivative. So our u, like in the first problem, I took one those who haven't belong inside the parentheses, making it u equals to x squared plus 7. So du is 2x since 7 is constant. What we need here is dx, so times dx here. So in order to get the dx here, we just have to place 2x here, divide it by 2x, and then this one will cancel since it's 1, and this will remain, making it once again du over 2x equals dx. Then we just bring down the 4 here, 4x here. And then instead of the equation of x squared plus or x squared plus 7, it will become u over 4 du over 2x. So we're gonna divide this one by 2, making it 2. We just isolate it for now. U 4. So this is a problem or an example in general integration formula, which is u substitution. So our problem is integral of 3x times x squared minus 9 cubed. First, we need to identify our u. Our u here is x squared minus 9, since the way I identify it, if it has an exponent and if it is inside open and close parenthesis. So our u will be x squared minus 9. I placed d over dx here. And then find the derivative of du, which is x squared has become 2x, and then we just cancel 9 since it's constant. And the third thing, we want to get the what we need here now is our dx, or so that's why we have to bring this as our numerator, and we need to cancel the 2x here. So in order to cancel this, we have to multiply our equation with dx, and now just take out the 2x here. Through that, here's now what we got, du over 2x, and on the other side, instead of 2x here, we're gonna be placing here dx. So now the next thing we need to do is bring here the 3x, or the integral of 3x, and since we substitute it as u, we're gonna put here u instead, u over 3, u in the third power, and du over dx. Now we have this equation. Just put du here, and then it will come 2 times, using the power formula, which is u 4 plus 1, then 4 plus 1 plus arbitrary constant. Oh, apologies for this. I will just transfer it here. Now it will become 2 times u to the 5th power over 5 plus c. And then the next thing we need to do is just multiply it, so it become 2/5 or 2 over 5 u5 plus c, and then what we're gonna do now is substitute it back again, so it become 2/5 times what we had substituted a while ago, which is x squared plus 7, and then don't forget the to the 5th power here and the arbitrary constant. So this is the final answer. And